In this video, we have to find the domain and range for the step function that's on the right-hand side here. So for our domain, we're counting every single x value it's possible to use in this graph. I'm going to go ahead and use interval notation here. So I'm going to find the furthest to the left I can go, which is right over here. It starts at -3. And I want to see if there are any x values that I have to skip on this graph. So it starts at -3. That's a solid circle, so it's included. Over here at -2, I can see that I have an open circle, but I also see that -2 is included in the function above it, so I haven't skipped that number. I haven't skipped this number, and if I go through and check through all my open circles, I can get to the x value if I look at the piece to the top of it. So here, I can go through that open circle and I get to the value right there. So it looks like I can hit every single value on this x-axis, and the x values that are labeled for me are starting all the way at -3, going all the way up to +3. So that's going to be it for my domain. For my range, we're going to do something similar, except this time I'm looking at my y values, and I want to see if there are any y values that I skipped. So let's take a look on my range. The lowest I can go is -3, but as I see here, I go up to -2 and I skip every single y value in the middle. I don't hit any of them in between. The same thing happens between -2 and -1. I skip all of those. So it looks like instead of having an interval, this is going to be a list of y values that I can get to. So for my range, I'm going to have a list. I can get to the number -3. And then I skip everything between that, and the next value I can get to, -2. I skip everything until I get to -1. Then I can hit 0, then I can hit 1, then I can hit 2, and right here at this one dot, I can hit the number 3. And that's it for my y values. I don't have anything in between there. So my y values for this step function are just a list. Let's go ahead and take a look at question number 10. Question 10, again, is a step function. It says, Mark and Emily have been selling business t-shirts to local public schools. Here's the price per shirt on the side, based on the number of shirts that we want to buy. And our first question says, if the school orders 80 t-shirts, what price per shirt will they pay? So that's just asking you, if I input the number 80, what is my output going to be? So I have to go over here to 80 on my graph, and I have to try and figure out where my output is. I want to figure out which function inside this step function cares about the number 80. The first graph I seem to hit is this one all the way to the right, but that's an open circle. So I can't actually get to the number 80 in that portion, which means I'm going to go straight through it, and I'm going to keep looking to see where I hit. And I actually hit at that dot right there, which tells me my price per shirt is 10. This is $10 per shirt. So if I order 80 shirts, I will be paying $10 per shirt. The next question here is asking us, between how many shirts does the school need to order to pay $15 per shirt? So if I want to pay $15 a shirt, I want to know which interval is going to have those values for me. So $15 a shirt is right here, which tells me that these are all the values where I can pay $15 a shirt. And it starts over here at 20 shirts, but it doesn't include it. So it starts at 20, but doesn't include it. And it goes all the way over here to 40, and that does include it. So if I'm writing an interval, it's going to be from 20 to 40, where 20 is not included and 40 is. If I want to say that with words, I have to say it starts with more than 20 shirts and up to 40 shirts. So that means I can get up to 40 shirts, and I'm including that number. And that's our interval. Let's go ahead and take a look at question 11. For question 11, we're going to be doing composition here, and we want to figure out if these functions are inverses. So again, composition means I'm plugging something into another function. So this first one says I have to take g of x and plug it into f of x. So f of x is here, g of x is here. We're going to go ahead and start with g of x, x minus 5 over 2. We're going to take that and plug it into f of x. F of x takes the things I plug in and multiplies them by 2, and then adds 5. So that's going to be our job here. Now the first thing f of x wants to do is multiply this inside function by 2, but my inside function is being divided by 2 as its last step. So those two are going to cancel each other out. That's going to give me x minus 5 and the remaining plus 5. Now my f of x function wants to add 5, but we're already subtracting 5, which means those are going to cancel, and it looks like I'm going to get x completely alone. Let's see what happens when I plug these in the other way around. Now we're going to be taking f of x and plugging it into g. So let's take my f of x function, which is 2x plus 5, and our job is going to be to take that and plug it into g. G takes everything we plug in, subtracts 5, and then divides by 2. So let's go ahead and see what happens here. The very first thing this g of x function wants to do is subtract 5, but the last thing happening in f is that I'm adding 5, so those are going to cancel. I'm going to get 2x, and the remaining divided by 2. Now g of x wants to divide by 2, but I'm already multiplying by 2, which means I'm going to get x by itself. Now, if I compose two functions and I get x alone, that means that these functions are inverses. Let's go ahead and pick up with the last question from this review packet, question number 12. Question 12 is asking us to graph these piecewise functions and to find the domain and range and some inputs. So let's go ahead and take a look at graphing this first function. This function is made of two pieces. It's made of this line right here, negative 2x minus 1. That's in slope-intercept form. So let's go ahead and figure out where that would live. The minus 1 is my y-intercept, so that's going to show me where I hit the y-axis. And the negative 2 is a slope, which tells me how I move away. So this says I have to go down 2 over 1. So down 2 over 1, there's my next dot. And I'm not actually going to connect these yet. I'm just going to get a good idea of where they go. And to continue my slope to the left, I'm going to go up 2 to the left 1. And this is going to show me where my path is going to be. So my line is going to follow this path right here. But I don't want the entire line. This has given me an interval that I care about. It says I only care about the x values that are less than or equal to the number 2. So x equals 2 is right here. So I only care about where that value hits this equation. So it starts right down here. That's where my x value is 2 for this equation. And it says less than or equal to, so I'm going to include that 2 in my interval. Now my x values are less than 2 when I go to the left on my graph. So I'm only actually going to fill in the line on the left side of this graph. And I'm going to do a better job than that. Here we go. So the left side of my graph is all that I care about. Now I can either go back through and erase this last dot or leave it there as long as the only line I filled in is the line to the left of the number 2. Now let's try to do the same thing with this line right here, negative x plus 4, which again is in slope-intercept form. My intercept is the number 4, and this slope is negative 1, which is down 1 over 1, down 1 over 1. So these dots here are showing me the general path for this line as I move away from that intercept. So that's what my line is going to be filling in. But again, I don't want the whole thing. This interval tells me I only care about this line when x is greater than 2. So again, 2 is my boundary, and I want everything where x is greater than 2. So I'll find 2 on my graph, which again, 2 is right here, and it's going to touch my graph at this point, but this point is not included. So I'm going to put an open circle there. So that's the first place on my graph I'm going to draw, but I'm going to use an open circle to draw it because I'm not going to include the value 2. And I care about all the x values greater than 2. We are greater than 2 to the right of 2. Everything to the right of 2 is bigger, so I'm only going to actually draw this graph to the right. And again, everything that I didn't use, these extra dots, I can erase, or I can leave them as long as the only actual line that I've drawn is the line to the right of that cut. So I've only drawn the right-hand portion of that line. Now, if I wanted to find the domain and range, I would try and figure out how far to the left I can go, how far to the right. So starting on the left, I can start all the way at negative infinity. As I move to the right, it does cut at 2, but 2 is included in this portion down here. So I haven't skipped 2, and I've included everything to the right of it. So my domain is actually going to be all of the x values, negative infinity to positive infinity. There's no x value I can't fit in somewhere in this graph. Every single x value has been picked by one of these teams. For my range, I have to figure out from bottom to top if there are any y values that I have skipped. Now it looks like this point here is the lowest I can go. However, this does have an arrow that tells me that this line keeps going down below that. So I can get to smaller y values if I use the green portion. And this red portion does include all of the y values above this point. So it looks like, even though I have some overlap in the middle, that's fine. We're allowed to have overlapping y's. It looks like because of the arrow going down here and going up over here, I can get to every single y value as well. So I can get all the way down to negative infinity I can get all the way up to positive infinity, and I have no gaps in between them, no y values that are skipped. Now my job is to go ahead and find f of 6 and f of 0. So to find f of 6, I have to look at which portion of my graph cares about that x value right there. The portion of my graph that cares about it is this green line right here, and this green line should be going through 6 at the x value -2. And I know my graph is a little sloppy, but I could also use the green equation right here and plug in the number 6 to it because 6 is greater than 2. That would plug in 6 to the x value, -6 plus 4, and that would give me the x value, the y value, -2. The next thing I have to do is plug in f of 0, so I have to see which function cares about the x value 0, and that's going to be this function right here, which is the red line. And at 0, my function goes through the point -1. That was the y-intercept of that red line. So if I plug in 0, I get out the y value -1. Now we just have one more question to look at. Again, it's piecewise. We're going to graph these 3 pieces and find domain and range and some values. So let's go ahead and see what we can do here. My first piece is going to be this constant. No matter where I am on my x-axis, this line is always going to go through y equals -4, which is right here. So these dots in red show me where all of my outputs are for my potential line, but I'm not going to use the entire thing. I only care about it when x is less than or equal to -2. X is -2 right over here, so I'm going to go down to my line. X is less than or equal to, that tells me I can get to -2, and I only care about the x values smaller than -2, which are the ones to the left. So I'm going to draw this line to the left. Then we're going to be ready to look at our middle piece. Again, I can erase these extra points, or I can kind of just leave them as long as the only line I've actually drawn is to the left of -2. My next piece is x minus 2. That's a straight line, so it starts with a y-intercept of -2, and that x has an invisible 1 in front of it. That's a slope of +1. So here are the dots that guide this line, but we don't necessarily want the whole thing. Let's go ahead and figure out where we care about this one. We care about this one when our x values are between -2 and +2. So -2 we already circled, +2 is all the way over here. We only care about the x values between these. So I don't care about these ones, and I don't care about these ones. I only care about the ones in the middle. So I'm going to start with this x value here at -2, this one, and this one at +2, that was the one right there, I kind of covered it up. Those are my 2 x values I care about. I only care about all the values in between them. So I'm going to fill in the line between those 2 points. Now, neither one of these endpoints was included, so I'm going to use open circles on both sides, but I'm only going to fill in the actual lines between those 2 points. And you'll notice the open circle on the left has been filled in by the value on the red equation, which we already had included. So that x value does have a home in the red portion. It just lives inside the open circle of the green portion. Up next, we're going to try graphing this line right here. Again, it's in slope-intercept form, -2x plus 4. We're going to start with that plus 4. And the slope -2 tells me I have to go down 2 over 1. So these are the points here that it looks like I'm hitting, down 2 over 1. There we go, and we can go up and to the left the other way. Again, we don't want this whole thing. We only want the x values greater than or equal to 2. So here's 2 on my x-axis, already circled in yellow. I care about greater than or equal to. So since I care about equal to, I can put a big solid circle, and you'll notice it fills in the empty space for my green function. And I only care about values bigger than 2. The x values to the right are bigger than the number 2, so I'm only going to draw the portion of the graph to the right of that solid circle. Again, these extra dots I can erase, or I can leave there as long as I've only actually drawn the graph to the right. There we go. So this is what my function looks like. It's made up of these 3 different pieces, which make this kind of slope-dude mountain range almost. Let's go ahead and find our domain. This portion in red can go all the way to -infinity. In the middle, every single x value I skipped in my green equation was filled in by one of the x values from my other equation. So I haven't skipped any x values in the middle, and this blue portion can go to the right forever. So I have every single x value as part of my domain. For my range, let's see how low and high I can go. So this arrow down here sends me downward forever. So my range does start at negative infinity. But this function over here has an arrow on it, this one to the left, but it's only sending me to the left. That's never going to get any higher. So the only part of this graph that goes higher is this part that goes up to the x-axis, but my function never actually gets any taller than that. So this function can go all the way to negative infinity, but it can never get taller than y equals 0. So all the way from negative infinity to 0. Everything else is included in somewhere in this equation. Next up, let's figure out what f of negative 1 is. I have to figure out which function cares about negative 1 on my x-axis, and it looks like it bumps right here into the green equation. And the point it bumps into is negative 1 on the x-axis and negative 3 on the y-axis. I could also figure that out by plugging it into this green equation, because negative 1 is in this interval between negative 2 and 2. And if I do negative 1 minus 2, I get that same output, negative 3. Up next, I'm going to figure out which piece cares about the number 2, f of 2. F of 2 happens right here, and it touches both the green equation and the blue equation. But remember, the green equation doesn't actually care about the number 2, only the things less than 2. The blue equation cares about all the things including the number 2. So if I'm going to plug in something to the number 2, I have to plug it into the blue function because that's what cares about 2. And it cares about 2 right at the y value 0. So I can either look at it on the graph and see that it's hitting right here on the x-axis, which is y equals 0, or I can take 2 and plug it into this blue equation. Negative 2 times 2 is negative 4. If I add 4, I get that same output of 0. And that's it for our review. I hope you guys study well for the test. See you tomorrow.